Welcome to Smart Chains Connection tutorials. Today I'm going to give you the basic rundown of what gas costs are on the Elrond network. I'm going to go a little bit into how to calculate that and give you some examples for reference and teach you how to dig into learning what exactly gas costs are and how that works when you're running transactions and when you're creating smart contracts and making calls to those smart contracts. So to start off, come over to Elrond docs.elrond.com, and just up in the search bar, search gas, and we'll go to the first piece that pops up, cost of processing gas. So I'm going to go over this page a little bit. I'll try not to read every line, but this is the first page that you need to read if you want to know anything about gas costs on the Elrond network. So gas, think of gas to run something. And your gas has a charge per unit. So instead of dollars per gallon, you have a cost per unit. And so each transaction has a processing cost, and so do deployments of smart contracts and running of those contracts. Each Elrond transaction has a processing cost expressed as an amount of gas units, and each transaction must provide a gas limit, which acts as an upper limit that you're willing to pay in gas fees. And so there is a maximum gas that is allowed on the network, which limits how much data you could incorporate with your transaction, and also how in-depth of a smart contract you can make, and how much a call to that smart contract would consume of the resources. So, constraints. For any transaction, the gas limit which you provide must be greater or equal to the minimum gas limit, the ERD min gas limit, which is a specific definition in the network, but smaller or equal to the ERD max gas per transaction. These are part of the parameters of the network. So, how do you look at what the current parameters of the network? Well, they give you a link right here. So let's follow that. Here we have some REST API calls that we can make. And the first one is the get the network configuration call. Okay? And they give you an example right here, but we're going to actually run it. So you can do this in your browser if you just want to look at it. And so when you run this is going to be the most current parameters, which will probably change. But the first one we're looking for was that ERD minimum gas limit, which we just talked about. And that's 5 with 4 zeros behind it. And since we're dealing with some pretty large numbers here, I may refer to these numbers in their scientific notation. So in this case, 5 times 10 to the 4th power. And let's come back to our docs where we are following this guide. And so we wanted to look at the minimum gas limit, which is defined by the network, and the max gas per transaction, which is defined by the network. Max gas per transaction. And here you'll find that's a 6 with 8 zeros behind it. So 6 times 10 to the 8th power. And this is the max gas units that you can provide when you make a transaction or a call to your smart contract. So, gas limit. They talk about gas limit for any transaction. Now, this is not provided by the network. This is what you provide. And let's go ahead and look at an example of a transaction where we would define a gas limit. And the most basic one is when you send in your wallet, but you'll also be doing this on in your code or from the command line using ErdPy to deploy and whatnot. So if you're using that, you're already familiar with gas costs, but here we want to go a little bit further and look into that. So as you can see, this is automatically calculating a gas limit for me based on the amount of characters that are down here in the data page. So each character is being represented by 1 byte. And how I know that is when I put in 1 character, that comes up by 1500. This 1500 number is the cost per byte that you're being charged for data. And so this gas limit is what you have to provide. And another thing you'll find is that the amount of that you're sending in the transaction does not have any bearing on this number here, but what does is the data that's going along. So if I didn't have enough, we'd get a red text that says, hey, you need more, because we have data down here. And we can hit this button, this refresh button, to ask it to recalculate. And if it doesn't auto-populate for you, just click on it and then it'll tell you in red text, hey, you need to be above this amount. Let's add a few more characters in here and it'll recalculate for you. So 1500, where does that come into place and where is that defined? So over on your network configuration data, you have ERD gas per byte. So for each byte that you're sending along, you have 1500 gas units. Now remember not to get your gas units confused with actual EGLD costs. So we'll see it in the docs, but this is the next thing that we're going to look at. And so the gas price, the minimum gas price. So this is the number you multiply your gas units by. And we'll get to that in 1 second. Cost components, the actual gas consumption. Okay, you have used gas and remaining gas. This is broken down into 2 used gas components. So essentially, the gas that was consumed is made up of value, movement, and data handling gas, and gas for contract execution. In the transaction that we were just making here, we only had the components of value, movement, and data handling. And so for that type of transaction, it's easy to know how much gas you're going to need to use. The contract execution part of this requires running a simulation, and that's the only way to really know how much gas your transaction's going to use. Okay, so this is an important one. Simple transfers of EGLD only require value, movement, and data handling component of the gas usage. That is, no execution gas. And the smart contract calls are going to require both of these, right? So here's a formula for determining your gas costs when you are not making a call to a smart contract. Okay, processing fee. So there is a processing fee, and we're going to look at that we're going to look at an actual transaction and see this processing fee right here. Measured in EGLD is computed with respect to the actual gas cost, broken down into its components, and the gas price per unit. So essentially they just go ahead and multiply that out for you. gas price per unit for the value movement must be specified by the transaction and must be greater than the network parameter called ERD minimum gas price. The gas price unit for the movement and data must be specified. So by must be specified, they don't necessarily mean you have to put it in. So it is specified right here, but you can't change that. So on the note of providing a gas price, as you can see, we have a minimum gas price, which means that you could provide more than the minimum price. In Bitcoin, this is done to get you ahead of the transaction list. So if you provide a very low fee, you'll be put on the back of the list and you'll be kind of at the back of the line. I guess from what I'm gathering, that's the same case here, though in Bitcoin, transactions do get delayed, and there's a very it's slow to process the demand of transactions. But in Elrond, that shouldn't ever be the case. So providing a higher gas price probably should never be anything that we would need to worry about. But it is there as an option. So it is to be provided. So let's look at a couple of examples of transactions. So let's first look at using ErdPy and see what's required there. So I'm going to call this function in my contract. I have the address, the chain type, which is DevNet. I have my PEM file, and then I have my gas limit right here, then my function, and so on. Nowhere in this call do I provide a price, but if you post through other methods, such as a REST API call, you do. In this REST API transaction example, we have the version and chain ID, which seem to be backwards in this example. Then there is the nonce and the value. So this is the value of atoms of EGLD. Then we have the receiver, the sender, and here's that gas price, which is the normal minimum gas price. And here's our gas limit. While the minimum is 50,000, that's going to be your base fee. Plus we have some data. So food for cats, that's our data. And so that brings our gas price up there. And here through this method, they give us an example of sending multiple transactions, and they're just linked together in the JSON file here. And as we can see, there still is a requirement of that same price per transaction. So no matter how many you link together, there's going to be, each transaction is going to have that gas price, even if you link them all together. Some other REST calls that you may want to look into is the simulate API, and then the estimate cost of transaction. You can throw in some parameters, and it's going to just give you back, hey, this is how much gas you need to provide, and it will be based on how much data you send along with it, not the value that you are sending. So there you go on that.